Alright, so today we're going to talk about 12.4, find sums of infinite geometric series. So the sum Sn of the first n terms of an infinite series is called a partial sum. The partial sums of an infinite geometric series may approach a limiting value. So consider the infinite geometric series 2 plus 2/3 plus 2/9 plus 2/27 plus 2 over 81 plus it goes on forever, hence why it's infinite. It wants us to find and graph the partial sums Sn for when n equals 1, 2, 3, 4, and 5. So when s equals 1, I'm just looking at the first term. When s equals 2, I'm looking and adding the first and the second, the sum of the first two terms. So for the first term, s of 1 is just 2. For s of 2, it's the first term plus my second term. For s of 3, it's my first term plus my second plus my third. We'll come back and simplify these in a second. My fourth is s of 4 is my first term plus my second term plus my third plus my fourth. So 27 there. And then s of 5 is 2 plus my first term plus my second plus my third plus my fourth and my fifth. So if I go back and clean these up, 2 is just 2. Here I would have 2.67 or 2 2/3. Here I would get 2.89. Here I would get 2.96. And here I would get 2.99. If you look, the more terms that I add up, I'm going to get closer and closer and closer to 3. So when I graph it, my first term, I'm going to label my y-axis by 0.5. My first term, or my x-axis, I'm going to go by ones. So if my first term was 2, or for my first term, s of 1 here was 2. S of 2 is going to be 2.67. S of 3 is 2.89, and I'm using a marker, so it's kind of hard to see the increase here. 2.96 and then 2.99. So very, very close. I'm getting very, very close. That's the limit that my infinite geometric series approaches. So it asks us to describe what happens to s of n as n increases. Well, as n increases, s of n appears to approach 3. So as n increases, s of n appears to approach 3. So if we look for the sum of an infinite geometric series, the sum of an infinite geometric series with first term an and common ratio r is given by s equals a of 1 over 1 minus r. The biggest thing here is r has to be greater than or equal to 1. If r is not greater than or equal to 1 here, then there is no sum. Okay, so my r has to be greater than or equal to 1. So let's go on and actually find the sums of a few infinite geometric series. So if I look at the first one, I'm starting at 1, it's going to infinity. That means that it's an infinite. I know it's geometric because of the way that it is set up. Okay, so here, if I'm going to use s equals a sub 1 over 1 minus r, two things that I need. a sub 1, which we know is 3, and my r, which is 1/4. So when I plug that in, I get 3 over 1 minus 1/4, which is 3 over 3/4, which just simplifies to 4. So this infinite geometric series approaches 4. Okay, if I look at the second one, now they don't give it to me in summation notation. They just list the values and the terms. So I still know that my first term is -1/2. If I look here, I'm going from -1/2 to 1/4 to -1/8 to 1/16. What I'm doing here is just multiplying by -1/2. So that is going to be my r value. So when I plug it in, I get -1/2 over 1 minus -1/2, which cleans up to -1/2 over 1.5 or 3/2, and that simplifies to -1/3. So here my geometric series, my infinite geometric series, is approaching -1/3. I'm going to ask you to try C right now. So go ahead and pause the video. What you will realize here is to go from 1 to 3/2 then to 9/4 and then to 27/8. Well, my r value here, let's look. Here I'm multiplying by 3/2, multiplying by 3/2, multiplying by 3/2. So my r value here is 3/2. Remember I said my r value has to be less than 1. Well, this is 1.5. So since my r value is greater than 1, there is no sum. Alright, if I look at this next example, it says a rubber band ball is dropped from a height of 60 feet. Each bounce takes it to 2/3 of its previous height. What is the total vertical distance the ball travels? So vertical distance meaning up and down. So this ball starts here, it comes up or goes down, and then it comes back up 2/3 of the way. So here, I'm starting here and it's dropping 60 feet. Then it's coming back up 2/3 of that. Well, if I take 2/3 and I multiply it by 60, I'll get 40. Then it's going to go down again and then come back 2/3 of that. So really what you have here is two separate sums that you have to worry about. I have to worry about all of my down when the ball bounces down and when the ball bounces back up. So if I focus on when the ball bounces down first, my a sub 1 is starting at 60, and my r value every time it is changing by 2/3. So this is for the ball bouncing down. So if I find the sum here, it's going to be 60 over 1 minus 2/3, which is going to be 60 over 1/3, which is going to be 120. That accounts for all the times when the ball bounces down. Now I need to think about, well, the ball is going to bounce back up, and I have to take that into account. So for that, my first term is 40 right here. This is the first time that it bounces up. And the next, or in the r value, again, is still 2/3. So this is for the ball bouncing up. So my sum here is going to be 40 over 1 minus 2/3, which is 40 over 1/3, which is 120. And my mistake goes back up here. 60 divided by 1/3, I'm sorry, is 180. Hopefully you caught that before I did. Then to actually find the total vertical distance, I add 180 plus 120 to get my 300 feet. So the next example has us write as a fraction in the lowest term. So one thing that is interesting is we can express a repeating decimal as an infinite geometric series, and we can use the sum of the series to write the decimal as a fraction in lowest terms. So instead of having to use our calculator to actually get this value, we can use infinite geometric series and find the sum, and that will actually give me the fraction in lowest terms. So I'm going to go through two of these with you. If I were to write this as a geometric series, my first term here would be 24 times 0.01 plus 24 times 0.01 squared plus 24 times 0.01 to the third plus, and you keep going. So then here what I'm going to find is that my R value is 0.01. That is my common ratio. And my A sub 1 value here is going to be the 24 times 0.01, which would just be 0.24. So now if I used my sum of infinite geometric series, going back to the front right here, I can use that to get 0.24 over 1 minus 0.01. So that's going to be 0.24 over 0.99, which is the same as just 24 over 99. And then I see that both 24 and 99 have a factor of 3 to get 8 over 33 as my lowest fraction, or my fraction in the lowest terms, my simplified fraction. So kind of neat, all I did here was just multiply by 10 to get rid of the decimals, and then I realized that 3 goes into 24 and into 99, so I can divide both those by 3. So if I do one more with you, that's going to look like 72 times 0.01 plus 72 times 0.01 squared plus 72 times 0.01 to the third, and you continue on from there. My R value is still 0.01. My A sub 1 value, my first term, is 72 times 0.01, which is just going to be 0.72. When I write this into my formula here, I'll get 0.72 divided by 1 minus 0.01. 0.72 divided by 0.99. That's just 72 divided by 99. I know that I can pull a 9 out of both of these, so that's just going to leave me with 8 over 11. Alright, I'm going to let you try these next two. And if you do them correctly, for C you should get 13 over 99, and for D you should get 5 over 9. Alright, I hope you will watch this video and come prepared to practice more in class.